quantum dots are where the quantum magic happens. Quantum dots are nanometer-sized crystals of semiconductors. They're tiny, tiny crystals. They're made of thousands or hundreds of atoms, so they're bigger than an atom, they're bigger than a molecule, but they're still really tiny. And they have some very unusual properties that I'll be talking to you about today. Let's start by having a picture of what a quantum dot really looks like. Now, we can't use a regular microscope to see a quantum dot because they're way too small. You can't use a light microscope. So in order to see them, to know that we've actually made them, we have to use an electron microscope. And this is one of my students working on the electron microscope at MIT. And this is what comes out of the electron microscope. It's a little picture where each one of these little particles, these little crystals, is just a few nanometers in size. Let's start with something really huge to get an idea of scale. Something really huge, like the sun. The sun is 1 billion meters in size. Now, humans invented the meter because it's on the human scale, right? We like to measure things that are on the scale of a human. And I brought a meter with me. Come on up. There's a meter right here. Mia here is 1.25 meters tall. It's a great frame of reference. Now, compared to the sun, she's a lot smaller, right? So the sun is huge. In fact, the sun is 1 billion times bigger than Mia here. If I were a quantum dot, I would be tiny compared to Mia. In fact, a nanometer is 1 billion times smaller than a meter. So the quantum dot would be 1 billion times smaller than Mia here. The quantum dot, Mia, would be like the sun to a quantum dot, to give you an idea of scale. Okay? Thanks, Mia. Okay, so now we have an idea of scale. They're really tiny. They're bigger than atoms and molecules. They're still so small you can't see them in a microscope. They're as small as the sun is big to us. How do we make them? What you see here is our pot. This is where we do our cooking. The temperature is about 500 degrees Fahrenheit, 300 degrees Celsius. Okay, so you're going to see the movie of this being made now. So there's the chemicals in the syringe here that are going to make the quantum dots. This is at 570 degrees Fahrenheit. And you see the color of the quantum dots is red now. And as it's cooking, the color is changing. It's going to get darker and darker. They're getting redder and redder as the particles get bigger and bigger. And when they're diluted in the solvent here, you can see that they're different colors. And it's even more impressive than looking at them with visible light is to look at them under UV light. So we shine ultraviolet light on them. The big particles on your right here, the red ones, are bigger than the ones on the green ones that we're taking out of the pot a little later. Okay, so there's a size difference here. It's the